Hey guys, welcome back to the channel. Okay, so I am currently in the process of programming the Direct 3D class load assets, part of the uh, initialization of Direct 3D. So, and that's coming along. It's taking longer than I had hoped, but it is coming along. So I hope to have that ready fairly soon. But while we're waiting on that, I'm going to do a video, and I'm going to call this a design video, although it's kind of not, but we'll call it a design video, where talk about the old game a little bit and why it failed. What went wrong with Manifest Destiny? Because, make no mistake, it did fail. As far along as I was in the programming, ultimately we did not have a finished game done. So, and I want to talk about why, what happened, and more importantly than the whys of or what happened is how I would do it differently today if I were doing it today. So just to talk about it a little bit, we were somewhere in between pre-alpha and alpha, I would say. We had a working game. Everything was there, with the exception of one bit. There was only one thing in the game that didn't exist in some form to make it totally playable, and that was combat. And I'll talk about why that is in a minute. But yeah, everything else was there, and we even did do an inaugural game. Played a few rounds. It showed me some bugs that were in the game that I immediately went and fixed. Yeah, but the only thing that didn't make it a really a fully playable game was the combat system. That was not in yet. So that's the only reason I say we're somewhere between alpha and pre-alpha. It's because we were missing that. You really couldn't play. I mean, you could play, but there was no real ability to take over other players' stuff, which is kind of the point of the game, right? So yeah, I want to talk about what went wrong and how I would do it differently. Basically, there were two problems kind of killed Manifest Destiny. Two major issues, and they both hit at the same time. Both of these are ultimately my fault. One is directly my fault. One was more of a problem that could have been solved, if I'd given it a little more time, maybe. So yeah, let me talk about that. Problem one was to do with the world creation. So if you guys didn't watch the previous design video, the whole thing of this is a world is created, the players are placed on that world, and then they play on that world. I had a very complex world creation system. It was kind of Texel based. Land masses were created what I feel like was fairly realistically. I mean, it could have used some tweaking for sure, but everything was there. It was making pretty realistic worlds. The problem with it was that for any decent sized world, and these are round worlds, these are global globes that it was making, it took a really long time to build. On the order of biggest size was taking, on my computer at the time, something like 12 hours to generate a world. Now, I justified that to myself a little bit because, you build the world one time and then you play on it for a long time. Like it's a turn-based game, and you're passing turns back and forth. So you're probably playing on that world for weeks or months at a time. So, I thought, well, they just have to sit through it one time. They can let it go overnight. But it was a problem. It was an issue, with the game, and it hurt the game for sure. That's the one that I'm calling the problem. That's the one. Not necessarily, it was my fault, but I'm saying it's not directly my fault. It just was too complicated for computers at the time to really run through. So, how would I fix that today? Well, for one thing, computers are a lot faster now than they were 15 years ago. But even so, I think I don't really have a super great answer for this, except to say that I've learned some optimization techniques in the meantime. I think that could have been optimized to make it faster. For sure, it was a first pass at the whole thing. It still needed tweaking, and optimizing it at that point would have probably been premature. So even back then, I probably could have made it faster. If I were doing it now, I could make it even faster than that because I think I know a little bit more about optimization than I used to. But so, it wasn't an unsolvable problem. It was a problem, but I think it was solvable. Yeah. But having said that, even though it was a solvable problem, and I knew at the time it was probably solvable, it still hurt the morale of the project. Really, it hurt me because it made it clunky and difficult to work with. So yeah, it was a little bit of that was one problem. That was one huge problem. The second one is a little more complicated. The second one is the combat. So let me talk about the combat for a second. In this game, the players don't directly control the combat. It's not possible to do so. So, like, say you had 6 players playing on this one world, you can't sit and wait for 2 players to pass turns back and forth while they're resolving combat, right? So all combat was handled basically off camera, so to speak. And the way it happened was that combat would be resolved by on the host's computer, by the AI, and then it would kind of be recorded. I'm using recorded in quotes, but the movements and actions would all be recorded and sent back to the player through their file, and they would watch that to see the results of the combat. Basically, they control combat by controlling their troops and the methods their troops used, and the stats on those troops. They wouldn't directly control where those combat units went. If you guys understand what I'm saying, right? So the whole point of that discussion is to mention that combat had to be resolved by the AI. Basically, when 2 units interacted with each other and they were hostile, combat would ensue, and the computer had to deal with that. So I had to build an AI. Now, at the time, I knew nothing about AIs. Unfortunately, I did not know a single thing. To this day, I mean, I'm not an expert on AI. I know a little bit more than I used to. I've programmed a little bit in the world of AI now, but back then I knew absolutely nothing. Not a thing. I was a complete rookie with regard to AIs. And I made a decision, and it was the wrong decision. I made the decision that the AI, combat AI, would be controlled by a neural net using fuzzy logic and all that. Totally the wrong decision. Absolutely incorrect. But I spent several months trying to get that to work, and it never really worked. It never even really did anything close to what I wanted. So, I mean, that kind of bogged the project down, to be honest. It really crushed it under this weight of the system that I was trying to build that never really got working. And that combined with the fact that the world building was tedious and slow, between those 2 things, and they both came to a head right at the same time. And it killed the project, quite honestly. Which is really too bad, because had I made the right decision with the AI, it wouldn't have been that hard to do, and it would have worked just fine, and we could have moved on. So, what would I do different today? Let me pull up Excel. I think I'm going to do this in Excel. I think I can do it in Excel. Let's pull this over. Blank workbook, please. If I were to do this today, I would use a behavior tree rather than anything else. I think the behavior tree would work the best. So with a behavior tree, basically, we'll create a little box. This will be the starting box. So you set your units here, and we'll call this start. And we'll even center it so it's like in the middle. So you then have underneath the start box, and we'll copy that. And see how I can do this. Can I do it like this? Yeah, I can do it like this. And then you have a series of choices down here, right? And I don't know what we're going to call these, but so an obvious choice that they could go for is attack, defend, seek cover, you know, just some choices, right? Maybe retreat. I don't know. Yeah, no, what they are doesn't really matter. But the last one, so we'll just do A. We'll just, you know, just some choices. And then this will be, this last one I'm going to put in panic. Okay, so what you would have is a series of possibilities that are underneath the start. So this is where they start. And we're talking individual units here. So an individual unit would be here. And it's got to make a choice between these possible actions. And then how do I, oh gosh, I haven't done this in so long. I think it's insert shapes. Yeah, there we go. And then there's going to be a series of like lines. I won't put them all in, but there's going to be a line from the start to each one of these. Okay. Then what you would do is you would, for each of these lines, you would have a series of variables. And those variables could be things like the unit's current health, its morale, its training, its technology versus what it's up against. All kinds of stuff you could stick in here. What you want to do is stick a series of variables that apply to that unit into a formula and come out with a number. Some number, and I don't know, we'll just say some number X, and we'll even try to get it close so it's obvious that's what it's for. Okay. And then same thing for this one, and we do it for all of them, and this comes up with a number, Y and Z, and you know, all of the numbers. And what you do is you get a number, and the higher the number, the more probable it is this action is going to be selected. Then you add up all these numbers, and then you sum those. Sum this row, and then you normalize that from 0 to 1. So say this row ends up being, I don't know, 72. Then you just normalize it from 0 to 1. And then once you've normalized it to 0 to 1, you take that 72 and you put it back into these things. So if this ended up being, say, 20, then whatever that is, say this was a probability of 20, this would be equal to 20 over 72, right? Or 0.227. And same with this. And what that does is it ensures that these numbers, as you sum them up, all add up to 1. And then you just get a random number from 0 to 1. And whatever, it picks the one that goes to, right? That's basically a tree. Now, underneath there, so suppose we decide to attack. Or the dog. Bless you. Goodness. You okay? The dog just had a sneezing attack. All right. Poor girl. Okay. So what was I saying? So suppose they decide to attack. Then you come down here and you can have subcategories, right? You can have this category. Maybe he's got 2 or 3 possibilities down here, right? So you can have it lines down this way. And you just do the same thing, right? Say this is, melee attack, ranged attack, some other form of attack that they could do, right? You just have a series of choices based on the attack. They've decided to attack. And now these are your choices. And so you just keep going down. And then maybe this has a couple of, or maybe they pick this one. And this one has a couple of subcategories, like, one can go down to this one or this one. And again, same thing. You get probabilities for each one, you normalize, and you pick one. That's the idea. That's how I would do it if I were handling it today. It's really relatively easy to do. I mean, it seems complicated, but it's really not that complicated. You do have to play with these parameters to make sure that you get realistic behavior out of it. But if you do get decent realistic behavior once you've messed with these for a while, it works. I think this is the way a lot of games handle their AI. And one of the advantages of this actually is you can actually expose this tree to the player and have them modify it. So some things would be locked in place, like panic. Panic would be like if their morale is really low and their health is low and they're up against overwhelming odds and it overwhelms their training and they panic. So that one would probably be in a locked state of some sort. Some of these could be modifiable. Some of them you lock down. Some of them you allow to be modified. And the way they modify it is through research, training programs, stuff like that. Stuff that they can do in game that would modify these trees to make it more likely they would attack. Or you could even set behaviors for your unit types. I want this particular type of unit to defend most of the time, and you can increase that weight here. So you could expose this to the player and let them modify it somewhat based on their technologies and their abilities in the game. It's a system that I think would work. I think it would work just fine. It might require a little bit, especially things like movement, like seeking cover, retreat, would require a little bit more finesse to decide where that unit wants to go, stuff like that. But yeah. And then once they've come to an action item, you stop. Like, see, this is a decision, and you just keep going down until you reach the bottom, which becomes an action item. That action item is the one they implement, right? And then at the end of that turn, you just stick them back up here. Everybody starts over at the top again. I think that's the way I wanted to do it. You can even put a modifier to make it more likely that they'll come back down to the same spot, because if they're doing that one thing, they'll probably want to keep doing that one thing. So breaking that streak would be a little bit more difficult, but not impossible. So if they previously attacked that round, you may want to put a weight modifier on here to give a bonus to attack, maybe another extra 10% or 15% or something, to increase these numbers a little bit relative to the rest of these. That's how I would do it now. Actually pretty simple. It's not simple. Don't get me wrong. It's not trivial, but that's how I would do it if I were doing it today. And I think this is imminently doable. I could have done this myself when I was back 15 years ago, even without any experience with AI at all. So yeah, the path that I went down, the neural net, was a horrible decision. It was completely inappropriate for the type of game I was trying to do, and fortunately, it was instrumental in killing the project. Between that and the world building. So yeah. Anyway, guys, that's basically all I wanted to say. That's the long and the short of what happened with Manifest Destiny, where we got to, and why it failed, and how I would do it differently today. Give me your thoughts if you think I'm totally off base on some of that stuff, but I hope I'm not. But I'm always willing to hear you guys' opinions, especially if you know something about this more than I do. I mean, I'm a what I would consider a professional programmer, but not an AI programmer or a world creation programmer or whatever that is. But I'm making this stuff up as I go along a lot of times. So if you think there's a better way to do it, let me know. I mean, I'm totally interested in what you would think. So anyway, yeah, that's all we have. I am working on the Direct 3D class. Like I said, the load assets part of the initialized Direct 3D. I'll be super glad when we get past it, because honestly, I hate this part of the coding. Initializing Direct 3D is not interesting. It's really dry and boring and full of stuff like this, where you have to fill out structures. Did I finish this? Yeah, this is right. Yeah. really only that one big structure, huh? Yeah, it's fine. It's fine. We'll get through it. We'll get it done, and then once it's finished and working, then we can come back and modify it to make it more applicable to our program. I think I'm going to want more than one viewport for our particular game. I think I want two. I think we'll see. See how it goes. Yeah. So anyway, all right, guys. Yeah, that should be coming in the next, hopefully pretty soon. I can't really tell you when. I'm hoping in the next week or so. I'm trying to get it done, but it's been a busy week, so yeah, it's coming along. It's coming along, so you should see it relatively soon. Why do I have a warning? I don't know. It says I have one warning, and yet it has 0 warnings down here. That's great. Ugh, IntelliSense. Jeez. Okay. All right, guys. We're gonna stop here. I will see you in the next episode with a programming video. So yeah, we'll stop here, and I'll see you then. Thanks a lot.